to recap our journey through the start of this unit, this is our third day. The first day was all things slope. Just straight up from a graph, from points, what is slope? Yesterday, what did we do? What did we do all day yesterday? What kinds of lines? Parallel and perpendicular lines. So we had a refresher on slope, we had a refresher on parallel and perpendicular, and now that we are comfortable with calculating and remembering all of that awesomeness from last year, now we're going to jump into our real-world application. So before we get into our notes, we're going to do a Batman question. Batman had 5 gallons of gas in his motorcycle. After driving 100 miles, he had 3 gallons of gas left. Do you think that's a good gas mileage?
No.
We'll see. The graph below shows Batman's situation. What are the coordinates of 2 points that you could use to find the slope of a line? Of this line. What 2 ordered pairs do you want to use? The ones that are already there? What would those ordered pairs be? Do I have to use those 2? So right now people are correctly saying those 2 that are highlighted, which is fine. I have a third one.
0 and 5.
So people are saying 100, comma 3,
0 and 5.
150, comma 2 would work. Somebody else saw this one. What's this one?
0 and 5.
Could I do this one? Yeah, this one's on. It's there, but it's just not highlighted for me. So we got multiple options here. Which 2 do you want to use? You want to use 50, comma 4? All right, so 50, comma 4 will be one of them. And 100, comma 3? Let's do 150, comma 2, because someone had voted for that one at the wave start. All right, so we'll use these 2. Does it matter which 2 I choose off of this line? No, it does not, because it's a constant rate of change. Yes. So the slope of the line. Let's first get some steps going here, okay? Let's define variables. What does x represent and what does y represent? What's x? So hold on. Number of miles for x. And y is gallons. And what's nice is that when we have a graph, we could literally pull it right off of the graph. So y is number of gallons. Now I need my 2 ordered pairs, so we're going to say 50, comma 4 and 150, comma 2. We pulled those 2 ordered pairs off of the line. The line on the graph. Now, we are going to have a very set way of showing our work, so we are all on the same page. We're going to write change in y divided by change in x equals, what are we subtracting up top? Careful. What are we subtracting up top? 4 minus 2. So that is why I do recommend you stack your points one on top of the other, because it's nice. It lines up the y values. So I have 4 minus 2, and then 50 minus 150. Could someone have done 2 minus 4? Yes. If they did 2 minus 4, what would they have to do on the bottom? Do the 150 minus 50. Good. Order matters. 4 minus 2. 2. So let's talk about what this means. Let's look. What is y all about here? Gallons? Yes? So this means minus 2 gallons of gas per how many miles? How do I know that miles is in the bottom? X, see how this nicely lines up? I trace back, X is miles. So this is a rate. 100 miles on 2 gallons of gas. That's pretty good. That's pretty high. But what if I want to know what's called a unit rate? Because usually nobody says, I can go this many gallons 100 miles. We say per mile. What does per, when you say in the real world per mile, what are you really saying? How many miles? Per 1 mile. So how do I get this to be per 1 mile? What do I do?
You divide by 2.
Very good. Divide. So we're going to take -2 divided by 100, and we're going to divide. Can you do that for me, please? What do you get? Mm-hmm. Negative, careful. It's not 100 divided by 2, it's 2 divided by 100. Yeah. Negative 0.02. Can I not? Let's see. So this is, let's talk about labels first. So now this is gallons per mile. So the question was, how can I have negative gallons? Does it make sense? Right. As he's driving his awesome Batman cycle, what happens to gas in the gas tank? It goes down. You're using it, so it's decreasing. Very good. If you were filling the gas tank, you would expect it to be a positive or negative? Positive. But he's driving and he's using that gas. Negative makes sense. So this kind of reasoning is going to be our focus for today. What I am passing out to you is actually going to span 2 days of class. We're going to do a couple examples in a row, and then we're actually going to move around a little bit and do the setups of some, and you'll finish the rest. So this is the plan. So as I'm passing this out, let's talk the plan. Tomorrow, I am on what's called a walkthrough in the building where I go through some other classrooms with some other teachers. So what I have planned is I have a recorded lesson for tomorrow. So the first 20 minutes of class will be a video walking you through the notes that we would have done together if I was here. You have tonight and roughly 15 minutes of class tomorrow to wrap this up. So the more you get done tonight, the better shape you are for tomorrow, because it will be due at the end of class tomorrow, and a separate worksheet is for homework. So the more you pay attention today, you're welcome. The more you pay attention today, the more you get done tonight, the better shape you will be for tomorrow. Let's make a decision. What are we selling? Who wants to have a company? Who has a company in this room?
Me, I do.
Okay, what's Lewis selling?
Shoestring.
Shoestrings? It's a very exciting business. That would be profitable. All right, we'll go with Lewis selling shoestrings.
No, shoes.
Shoes? So Lewis is starting a new company selling shoes. In 2009, he, it's more fun that way, had a profit of $173,000. And in 2013, the profit was $197,000. I'm told to find the average rate of change. Now, we are going to follow 3 steps for every single one of these questions. You already have good practice with the first one. Define what? What do we always define? Starts with a V. Define variables. So we'll use X and Y. Now think back to Algebra 1. When you were asked to define variables in Algebra 1, we were always looking for 2 measurable quantities. No matter what scenario I give you, there's 2 measurable things. Do you see one?
2013, 2001.
What is 2013, 2009 in general? What is that? Time measured in years. So we're going to say X is number of years. But we're going to have what we call a 0 year. What is the 0 year in this situation? Number of years since, yep. What was the starting year? So we're going to define years as number of years since 2009. And that would be my initial year. Now, what's Y? Once I know how many years have gone by, what's the other measurable quantity? Profits. Now, profit, total profit, however you choose to write it. One thing I would like to touch on. See how this is 173,000 and this is 197,000? We can help ourselves out and work with much smaller numbers if we define profit measured how. We're going to say Y is profit in thousands. And let's see what happens. So with those defined variables, please get me 2 ordered pairs. That's the next step. I need 2 ordered pairs stacked on top of each other. Ms. J142? Hi. Hi. I do. Yes. Who's got my first ordered pair? But I need, that would be a year, comma, year. Okay, but remember, 2009 is technically how many years after 2009? That's my 0 year, right? So it's going to be 0, comma, and then I heard 173. But I just have to write 173 because I defined this in thousands, right? See how nice that is? That's a nice ordered pair.
Wait a minute, 173. Oh! Wait a minute, you don't gotta add the zeros?
No, because we defined it to be in thousands.
And 2013, 197?
Well, let's see. So 2013 is how many years after 2009?
4.
So 4, comma, there we go. So this was step 1. That's what we do first. This is what we do second. Next, this next line of work is the most important part that we're all on the same page with. We're going to write change in Y divided by change in X equals. What are we subtracting up top?
They're right over each other, so you don't have to.
Yep.
Good job.
So 173 minus 197. That's why I do like to stack them, because it lines up my Y values and then it lines up my X values. So we're doing 173 minus 197 and then 0 minus 4 equals. Calculators. I have 2 up here. Anybody needs to borrow one? Negative 24.
Over negative 4, which is 6.
Let's show the work. Divide by negative 4 equals 6. Now, the reason why I stress the importance of showing this work like this is because if I go back, what is Y all about? Profit in thousands. So right now I'm just going to write 1,000, and we'll talk in a second. So that's 6,000, and then I trace back. What's X all about?
Years.
So that's 6,000 per year. See how this says the word 1,000? To get the number, we actually can just multiply by 1,000. So what is 6 times 1,000? So my little mini phrase or sentence would be $6,000 per year. It would be nice to say Lewis's profit increases. So let's do that. Let's make it even better. Lewis's profit, his profit increases at an average rate of 6,000 per year. And now we're done. So this was the final step right here. This is number 3, step 3. We're going to follow this process for every question. Why does it make sense that we say this is an average rate of change and not a constant rate of change? Right. Let's say, so you both are right. Business can't guarantee its profit every year, can it? Or even every month. Like around the holidays, what happens for all businesses? Profits go super high, right? But then what happens in between? Drops. But then it's suddenly Columbus Day weekend, everything is on sale. What happens to their profits? Goes up. So there's a natural flow to profit. Ultimately, the goal is that you are making an average amount of money every year, right? So over the course of those 4 years, on average, his business was making a profit of $6,000. But maybe 1 year it was $8,000, 1 year it was $5,000, and then up to a little higher, a little lower, a little higher, a little lower. But we found the average. Very good. So let's apply these same steps to number 2. Go ahead and read number 2, and let's follow the same process. What are we going to do first? Good job. So first, define variables. Second, what do we do second?
We find out points.
Find your points. So first, define variables. Step 2, get your points. Just do those 2 things. Define variables, get your points. And ask yourself, what's the 0 year here? I'm going to have a 0 year. Mr. 142? Hi. Yes. Okay, sure. Yep, thanks. All right, what are we saying X is?
Average price.
Number of years. Remember, time will always be my IV. Number of years since. Did anybody figure out the 0 year? 1980. Very good. I know that because of what it said right here. That's how I know my 0 year is 1980. What does Y equal? What? I don't think it's gallons. Price. Price, cost, however you would like to say it. Okay, step 1 is done. Now I need my ordered pairs. Who's got ordered pairs?
0.
Well, careful. 1980 is my 0 year, so 1985, 5, comma.
Where do you get 5
Well,
from?
1985 is 5 years after 1980.
95? Oh.
What's the price in 1985? 95 cents. How do I write that as a decimal? 9.5?
No,
0.95. No, good conversations. Good. So 5 comma 0.95, and I need my second ordered pair. Who's got it? 26? Is he right?
No.
What is he trying to find out right now? Because what's my other year that I know? So how do I figure out how many years after 1980 is 2011? What can we do? How can we use a calculator just to be sure? Subtract. Do 2011 minus 1980. 31. Good. So 31, and then what was the price in 2011? So we've defined our variables. We have our ordered pairs. What are we going to set up next? How do you say this out loud? Change in Y divided by? All right, let's work on that. Take it all the way to the end with units, please. Take it all the way to the end with units. How are you going to do this? Okay, do it. What did we get for the top? And then the bottom? So if your order was different, you would have a negative divided by a negative. We're still going to end up with the same answer. Who's got 2.11 divided by 26? Let's get 3 decimal places. 0, 8, 1. For the purpose of the SAT, we are going to practice going out to 3 decimal places. In a second, we'll say the real world answer. So 0.081. Now trace back. What is in the numerator for a label? Jeffrey? Dollars, right? That's what we had. So we'll put dollars for a second. And then per, and then what's in the bottom? So what's the measurement for X? What's the unit? Right? X is all about years. So now how do I make sense of this? What am I going to say? Gas increased. An average. I would fit average if I could. This AV means average. An average of how much? How much money is that? What is that? 8 cents. Very good. 8 cents per year. So for the purpose of the math itself and getting ready for the SAT, we'll take it out to 3 decimal places. But then in our brief little sentence, we'll get our real world meaning. 8 cents per year. Very good. What's different about number 3? It has a table. So go ahead and read number 3. Well, it says Maria took a trip on her bike. The table below shows the total distance she traveled. Find the average speed in kilometers per hour. Now, notice it says average speed. Let's see why it says that. Is X moving at a constant rate? Plus 20? Plus 20? I think you add 20 each, right? So that works. But now look, in the first 20 minutes, how many kilometers did she go? 5. In the next 20 minutes, how do I get from 5 to 20? Plus 15. See how it's now different? And that makes sense, right? If you're riding your bike, maybe you're like flying for the first 20 minutes and you chill for a little bit. Now you're going uphill, it takes you longer, right? Your speed is going to vary. So we're looking for the average over her entire trip. So which 2 ordered pairs does it make sense to use? Last one and the first one. Very good. We'll use her start and where she finished. Now, when I have a table or a graph, it's nice because I already can see what X and Y is. So X will be number of minutes or time in minutes. And what's Y? Distance measured in, what's the abbreviation for kilometers? KM. KM. No. Kale is a green leafy vegetable. Kilometers is distance. All right, so let's stack our points. We've got 0, comma what? 0, 0, and 100, comma 30. So go ahead, let's find, you do the last part on your own, change in Y, divided by change in X. Keep going all the way. We want a unit rate. So that would involve dividing. Remember, orders, it doesn't matter as long as you follow whatever order you're doing. How do we do? Do we match? Awesome. Okay, those are our 3 solid examples. Now, we're going to move around a little bit so we experience every type of question that's in this workshop. Let's move over to number 7, please. Let's move over to 7. Temperature of water in a tub is modeled by the function W, where W of T is measured in degrees Fahrenheit, T is measured in minutes. So for our own little side note here, let's say X and Y. X is minutes, Y is the degrees. And I'm told I've got temperature readings for the first 20 minutes. So here's the start time is 0, and then after 20 minutes.
So we're gonna pick both start and finish.
Well, let's see. A gives me some more specific directions. It says, find the average rate of change on this interval. From yesterday, does anybody remember how to work with this interval?
Nope.
Let's talk about it. These are both X values. So when X is 0, what is Y? From the table, 55. And when X is 9, 61.8. So you should make a note.
Wait, so when X is 0, Y is 55, but then when X is 9, Y is 61.8.
Hold on one sec. This is an interval. Both are X values. This is not an ordered pair. Okay, say your question again, or your statement.
So I was saying, so if 0 is, wait, so if X is 0, then Y is 5.
Yes, I pulled that right from the table. Yep. Yes. Yes, it's connected to what we did yesterday. So now that I have my ordered pairs, can we say change in Y divided by change in X and keep going? Yes. Now from here, we're just working on some setups, so that'll be for you. Practice using this interval. Use this interval. Please tell me what 2 ordered pairs we'll be using.
57.1.
Careful. What's my first X value?
4.
4. When X is 4, what's Y?
7.
There you go. What's my next X value? What's my next X value? There you go, 20. And then when X is 20, what's Y?
71.7.
Yes. Okay, good. Let's move over to number 9. Let's move over to 9. So cute. A zoo sponsored a one-day contest to name a new baby elephant. Aww. Zoo visitors deposited entries in a special box between noon, which is my 0 hour, and 8 p.m., which makes 8 p.m. equal 8. The number of entries in the box, T hours. What can I write next to here to help me out? X. X hours. Afternoon is given in the table. So what's this going to be? Y. Notice I'm told it's measured how? Hundreds. So 0 is 0, but what is 4 really?
400.
400. 13 is really 1,300. Very good. Keep that in mind. Now it says find the average rate of change, and it gives me this. How are we going to work with this?
Are we going to do it like,
Kind of like what we just did. So here's one, right? When X is 0, what's Y? And what's my other one going to be? So let's actually state 0, 0 and 5, 13. Let's do this one out together. So change in Y divided by change in X. What are we subtracting in the top? 0 minus 13. Careful, remember, these are nice in the line. 0 minus 13, and then what's in the denominator? 0 minus 5. That gets me negative 13 divided by negative 5 equals. 2.6. Now let's talk real quick about labels. What is Y? What's my units for Y? Per what? But how do I figure this out? Like, what do I do to get this to make sense? What am I going to multiply by?
By X. Wait.
Well, here, I asked you what 4 meant. 4 wasn't really 4, it's 400, and you did 4 times 100 to get that, right? So to figure out what this actually is, I'm going to multiply by 100. So do that, 2.6 times 100. We can just move the decimal, yep. Or multiply, whichever works better for you. So this really means 260 entries per hour. On average, for the first 5 hours. Yes. B is just talking about what does this mean. So it would be on average the first 5 hours, the zoo got how many entries per hour? What did you just find? Don't overthink this part, okay? It's just we're saying from noon to what time? What time is 5 correlate to? 5. Let's see, this is 12 noon. This is 8 p.m. What's 5? 5 p.m. So from noon till, excuse me, 5 p.m., the zoo got what? Received an average of 260 entries per hour. Good. All right, let's move over to number 10.
Wait. No.
Graph below shows the rate at which people enter an amusement park ride. Describe the intervals at which RT is increasing, decreasing, and constant. So let's talk about this. When you see that, I want you to, excuse me, get a list. So write increasing. Before you even do anything else, get a list. Increasing, decreasing, constant. Let me know when you see something I can write down. Anybody see an increasing space on this graph, Jeffrey?
Yes.
The first one?
Yeah, the first one.
What do you mean? You mean this right here?
Yeah.
So what interval? I need the x values. From what to what? From 0 to 2. So 0 to 2. We're not going to worry about brackets and parentheses when we're talking increasing, decreasing, and constant. We're just going to use parentheses. So 0 to 2. Are there any other increasing intervals?
No.
Nope. Okay. How about decreasing?
Yeah, from 4 6 to 8.
Very good. 2 to 4, and then again 6 to 8. 2 to 4, and nice job on that one. 6 to 8. Are there any constant pieces?
4 to 6.
From 4 to 6, and you're done. That's all that's asking. Now, B says find the average rate of change from t equals 2 to t equals 4. How are you going to do that? What ordered pairs do I use? Very good. Is everybody seeing where he's getting those? Yes, these are x values. When x is 2, where am I? 1200. Okay, so in B period, In B period, the only one we didn't get to is a setup for number 12. So I'm actually going to keep the video going for another minute. If anybody's going to lunch and you just want to hang out real quick to see the start of 12, you can. Otherwise, go online tonight while you're working on this and just watch the last 2 minutes to catch up on 12, all right? Have a great day. So from here, we're ready to just go change in y divided by change in x. The only one we did not get to, as I just said, was setting up number 12. So for everybody who is going online right now to watch this last piece, fantastic. Let's talk about 12. Now 12 is still talking about intervals. So these are both x values. So I ask myself, when x is -5, where is y? So this is an ordered pair that I need. Ooh, I don't want to use pink. So my first, the nurse needs to see you. -5, -2 will be my first ordered pair. My next x value from the interval is when x is -3, I say x is -3. Where's the y value? It's at 2. So -3, 2 is what I need. So I have change in y divided by change in x, and I can go from there. So an example for B, I ask myself the same question. When x is -3, where's y? Still at 2, good. So I have -3, -2. No, sorry. -3, 2. Don't fall into that trap. This is another x value here. So when x is -3, y is 2. What's the other x value we're going to look at?
-3.
We did -3. What's the other x value in that interval? Right here.
Oh, no, there's 2.
Yes. So I say to myself, when x is -2, where is y? It's at 2. Very good. And then you're ready to go again. Change in y divided by change in x. So
Would divide them, like,
I'll leave that one for you. When x is 3, where's y? When x is 5, where's y? And then you keep going. So from here, just to answer your question, you're using your two ordered pairs just like we've been doing. Calculate your slope. This is not in a real world scenario. Yes. So I would subtract my y values in the numerator, subtract my x values in the denominator, divide, and you're done. So what would that look like for A?
-2 minus 2,
Yep.
and then -5 minus parentheses, -5, -3.
Good job. -2 minus 2? What's -2 minus 2?
I don't know. I'm not good with that.
The last part says state whether the function is increasing, decreasing, or constant. So because I have a positive value, I know it's increasing. Right? Very good. Nice job.